Students, this is Unit 8, Area and Solids, Lesson 8.8, Spheres. So you're looking at this page. It says similarity, but it meant to be spheres. This needs to be done prior to May the 5th for A Day or May the 6th for B days. Don't forget a parent signature or guardian sign-off, as well as the date, time, location that you are watching this. Spheres is a very short lesson, so we're going to spend a little bit more time on review than we normally do. Okay, and so what we're going to do is we're finding both the surface area and the volume of a prism and a pyramid. And if you follow these steps, you'll never, ever get lost. Shade, trace, perimeter, base, equations. Circle, plug, chug. Shade, trace, perimeter, base, equations. Circle, plug, chug. Shade, trace, perimeter, base, equations. Circle, plug, chug. You should figure out by now, if I repeat myself more than once, you should be chanting with me. One more time. Shade, trace, perimeter, base, equations. Circle, plug, chug. Ready? Let's do this together. Don't be intimidated. This is not hard. Step number 1 is we're going to shade the bases. Remember, in a prism, the bases, they are congruent, parallel, connected by rectangles. So that would be those would be your bases. Okay? And then the perimeter of your base, let's go ahead and trace that as well. And there's a reason why you want to trace that. So the perimeter, let's find the perimeter of this right there. So we're going to start with that. So find the perimeter of the base, P equals. We see here that we can do 3 plus 4, but the problem is there's an unknown there. But this is a right triangular prism. If you don't know that triplet, you do the math, but honestly, you should know this triplet. It's called a 3, 4, 5 right triangle. So we're going to do 3 squared plus 4 squared equals unknown squared. This is 9 plus 16 equals unknown squared. 25 equals unknown squared, square root, and you get x equals 5. So to get our perimeter, it's 3 plus 4 plus 5. So we want to, over here, use a capital P, which means perimeter. 3 plus 4, 7 plus 5 is 12. So it's 12 units. That's our perimeter. That's it. Now we want to find the area of the base, the area of our base. And that's a right triangle. So we write base area equals, that's going to be leg times leg over 2, because it's a right triangle. That's 3 times 4 over 2. 12 over 2, our base is 6. So right here, capital B, our base is 6 units squared. Okay, now to find, last thing we want to do is find the altitude, which is also known as the height, and that I define as distance between the bases. So right here, you want to write h, because in all our equations, that's our height, is going to be 6 units. That's our height. Okay? Now we're going to write out our equations. Lateral area is the area that's not the bases. And the way we find lateral area, trace with me please, is we take the perimeter and then we simply times by the height. And that's going to give us all 3 rectangles here. So perimeter times the height. That's the rectangles all the way around. To get the surface area, we take whatever the lateral area is and we simply add the area of 2 bases. Make sure you use a capital B there. That means area of the base. And volume, that was the first thing you do. excuse me, is simply base times height. Ready? Now we always write your equation. So prism, lateral area is pH, perimeter times height. Surface area is lateral area plus 2 bases. Volume is base times height. Ready? Let's circle, plug, chug. Most of this we already have. Very slowly and carefully, let's plug this in. Perimeter. We already have perimeter. Perimeter is 12. Height. We already have the height. We have stuff all labeled out. That's 6. So we're going to go 12 times 6. And that gives us our lateral area is 72 units squared. That's our lateral area. Ready? Next one, surface area is the lateral area. So we already have that, 72 plus 2. That base right there means area of the base. Don't forget, capital B always means area. So we bring down that area of the base, which is 6. It's going to be 72 plus 12. So my total wrapping paper area is going to be 84 units squared. That is our surface area. Last but not least, volume. If we were to fill this with water or sand or just fill it with something, that would be volume. So we take the area of the base again, which is 6, times the height, which is the distance between the bases, 6. Our volume equals 36 units cubed. Now, some students look at that volume and it annoys them, the fact that the 36 is less than 84 and 72. So you think you're wrong. But warning, that 36 is not less than, because it's 36 units cubed instead of units squared. This is like saying I have 84 $5 bills, and this I have 36 $20 bills. So that 36 $20 bills is a larger number. Don't be put off by that. It's your units or everything. Once again, the key equations are lateral area is pH for prism, surface area is lateral area plus 2 bases, and volume is base times height. That's for a prism. Let's do a pyramid. Shade, trace, perimeter, base, equations, circle, plug, chug. Shade, trace, perimeter, base, equations, circle, plug, chug. Say it with me. Shade, trace, perimeter, base, equations, circle, plug, chug. One more time. Shade, trace, perimeter, base, equations, circle, plug, chug. So step number 1, we're going to shade and trace our base. There's only one, as it's a pyramid. So we shade and trace our base. Now, we find the perimeter of our base. You walk it around, the perimeter of your base, walk it around, and we see that's going to be 14 times 4. So our perimeter equals 14 times 4. Do your own math. It's going to be 56 units. So that's your perimeter. Area. This is just a square, so the base area is simply side squared, which is 14 squared. That's going to be 196 units squared. That is your base area. Now we have to do 2 different heights here. Our true height, also known as our altitude, it's 24. And we always use the variable h for that. So h equals 24. Problem is we don't have our slant height. Slant height is called the skier's height because it's the height you ski down. Ready? Ski down the side, right down the middle. There's your slant height. We use a cursive L for that. We don't have that. We are going to need it. So let's pull it over. We don't have that. We'll call it X. Let's write down what we do have. That is 24. Watch. From center to edge, squiggle. Center to edge. Ready? Center to edge right here, squiggle. Do you see that that is half of 14, which is 7? Now to find that, we're going to go 7 squared plus 24 squared equals unknown squared. I'm going to pause for about 30 seconds. You do your own math there. I will give you the answer, but make sure your math follows through with the answer. Okay, you should have gotten 25 there. That's your slant height. That's your cursive L. Now, the equations for a pyramid. The lateral area, that's all the area of the pyramid except the base. For a prism, it's perimeter times height. But we lose area. We lose area when we go to a pyramid. An area is a two-dimensional concept, so we're going to divide by 2. It's still going to be perimeter, but area is an outer wrapping paper concept, so we use the outer height. So for area, we use the outer height, so it's PL over 2. That's your lateral area. That's all of the area of the pyramid except the base. PL over 2. So now we circle, plug, chug. Ready? Perimeter. Pick it up. You already have it. 56 times slant height. You already figured that out. That's 25 over 2. You're going to do your math here. So 56 times 25 over 2. And that's going to be 700. So our surface, our lateral area is 700. We checked for units. We weren't given any units, so it's units squared. Okay. Surface area, that's the total surface area, including the base. That's going to be our lateral area plus 1 base. Now, we already have that base. So we circle lateral area. We come over here, and it's going to be 700 plus the area of 1 base. We already have that. Circle, circle, plug it in. Just add those 2 up. That's the total wrapping paper area of the entire pyramid is 896 units squared. Now, volume of the pyramid is base times the inside true height over 3. It's over 3 because it's 3 dimensions, and when you go from a prism From a prism to a pyramid, you lose volume, and you lose volume by 1/3. So once again, we already have the base. That's 196 times our true height, which we had. That's the inside altitude, 24 over 3. 3 goes into 24 8 times, so my final volume, 196 times 8, that's 1568. 1568, and that's going to be units cubed because it's volume. Okay, what I recommend you do here is I'm going to set the timer for 2 minutes, and I'd like you to just verbally walk yourself through these two problems. Please take the time to verbally just kind of go back and say, I did this first, I did this second, third, etc. There's multiple steps here, and the only way you memorize this is by verbalizing it. Now, the actual lesson after this, really short. It's not even 10 minutes. Don't panic. So take your time to actually do this. 2 minutes. I'm going to set the timer. So you should be rehearsing for 2 minutes. Verbally talk yourself through these problems. It'll help solidify the material. I'm setting the timer for 2 minutes. Ready? Go. Okay, now that you took the time to verbalize that, we're ready to move on. Now, I did all of that because you're like, that's a lot to remember. That's going to make it super easy because spheres are so easy. It's downhill from here. So when we do spheres, we keep track of these words: sphere, similarity, dimensions, radius, ratio, exponents. Ready? Okay. I love spheres. There's 3 reasons why I like spheres. 1, they are a lot easier to draw than what we have been drawing, like pentagonal prisms and octagonal pyramids. So they're easy to draw. To draw a sphere, and you don't have to do the whole artsy shading thing, but to draw a sphere in geometry, you start with a circle. And then all you need to do is wrap around that equator. And that equator, you make it solid in the front and dotted in the back to represent depth. And then you simply stick the center. Ta-da! You have a sphere. They're easy to draw. 2, because there's no flat surfaces, you don't have to worry about the difference of lateral area and surface area. 3, to work with the sphere, all you need is one measly little thing. You don't have to worry about slant height and true height and base and perimeter and all that hullabaloo. You only need one measly item. All you need is a radius. Okay, now we're only going to talk about 2 things about a sphere. One is the surface area, which would be the wrapping paper or like the felt of a tennis ball. And 2, the volume, which would be the inside guts. Let's just differentiate. Area is a 2-dimensional concept. Therefore, the surface area for a sphere, you want to write this down. How do you find it? It's 4 pi times r squared. You only square the radius there. That's it. That's the surface area of a sphere, 4 pi r squared. Now the volume of a sphere, volume is a 3-dimensional concept. So volume of a sphere, volume equals, watch carefully, 4 pi r, look, it starts almost exactly the same, by parentheses, radius cubed over 3. We'll go over the whys behind these in class. For right now, just brute force. So first off, I want you to make note, if you have a highlighter, I want you to highlight what these have in common. It makes it easier to memorize. Now, switch colors if you can. Ready? I want you to make note that that's 2, that's 3. Okay, do you see the association there? When we do surface area, it's radius squared. When we do volume, it's radius cubed. Take about 20 seconds and just verbalize what's going on here. What pattern do you notice? I'm going to pause. 30 seconds. Verbalize that. Okay, let's actually put this to work. It says, wow, this instructions are wrong. It's talking about a cylinder. We want to find the surface area and volume of a sphere. So we're going to write out our 2 equations for surface area. It's 4 pi r squared. And for volume, 4 pi r cubed over 3. Ready? Let's do what we can. This 8, we trace it. That is our radius. That's going to go right in there. So we go 4 pi, 8 times 8, which means we're doing 4 times 64 pi. So our final answer is 256. Don't drop the pi. Check your units. That's area, so it's inches squared. Ta-da! You're done. That's it. That's the wrapping paper of the sphere, or the felt of a tennis ball, the outer felt of a tennis ball. Let's try volume. That's going to be 4 pi 8 cubed over 3. So that's 4 times 8 times 8 times 8 over 3 pi. Now that 3 doesn't reduce, so we're just going to multiply straight across. right here. 4 times 8 is 32. 8 times 8 is 64. So we have 2,048. 2,048 over 3 pi, and this is going to be inches cubed. Ta-da! You're done. That's it. This way, I don't need to get it all to a decimal. If you have to use it for something else, that's fine. But if you just want a final answer, pi fraction form is actually what's preferred in trig. Let's try one more problem together. It says right here, the surface area of a sphere is 1,809.557 centimeters squared. Find the volume. Okay, let's look at what we have. We have the surface area. It is. So let's by writing our equation. Surface area equals, for a sphere, 4 pi r squared. But we actually have the surface area. It says it is that. So our surface area is 1,809.557 centimeters squared. We want to find the volume. Remember, the only thing you need is the radius. Problem is we currently don't have it. But let's look at what we do have. You see those are equal? So we can make them equal. We can write 4 pi r squared equals 1,809.557. Our goal is to get the radius by itself, because that's all we need is that radius. So I'm going to start by dividing by 4 pi. Get your calculators out. So I'm going to go here, 1,809.557. First, I'm going to divide by 4. Then I'm going to divide by pi. Okay, take a look here. See that 99999? So that technically means this could be a whole number. So I'm going to have r squared equals 144. We're not quite done now. We need to square root both sides. Now we just found our radius. Ta-da! The radius is 12. You think you're done because you did a lot of work and you solved for the radius, but always double check what you're looking for here. We're not looking for the radius, we're looking for the volume. So we write our volume equation out. 4 pi r cubed over 3. Now we plug it in. 4 pi, 12 times 12 times 12 over 3. Why did I do that? Because we can reduce. 3 goes in here 4 times. Now I'm going to just multiply straight across. I'm going to get 4 times 4. $16 times 12 times 12, which is 144, 2304. So our volume equals 2304. This is pi form. Units. Whoops, nope, we don't have units. We have centimeters. It's going to be centimeters cubed. Find this page in your reference booklet, and we're going to summarize what we've learned so far. Okay, now you're in your reference booklet. It's practically the last page or very close to it. Let's summarize what we know so far. Let's start with volume, because volume is the easiest. Okay, volume for a prism is simply base. Volume equals area of the base times the height, which is the distance between the bases. A cylinder is exactly the same thing. Volume equals area of the base, capital B, times the height as well, which is the distance between the bases. A pyramid and a cone have the same volume equation. They both come to a vertex. When we're dealing with volume, it's 3D. So our fraction from prism cylinders is going to be over 3. So once again, you find the base, capital B, times the true height, which is straight down the middle, over 3. A sphere volume, that's 4 pi r cubed over 3. Surface area. We find surface area by finding first the lateral area. We do that by finding the perimeter of a base times the height. That gives us all the rectangles plus the area of 2 bases. Notice that's a capital B. That means area of. Just write the word area so you remember that. A cylinder, you do a circle around. Technically, that's perimeter, but we don't call that perimeter. In a cylinder, we call that circumference times height. That gets you this shaded wraparound piece, plus the area of 2 bases. Again, there's 2 of them, and that capital B means area of. So stay real close. You think there's a lot to memorize, but these 2 rows are exactly the same thing, except for one tiny little piece. Technically, they are the same thing. They're just 2 different names. Okay. For a pyramid and a cone, the difference for both of these is that we only have 1 base now, not 2. We have 1 base right down here. We have only area and 1 base. Remember, that means area of a base. Now, to get your triangle lateral areas, you find the perimeter times that slant height. And it's over 2, because area is 2 dimensions. This one, we find the circumference times the slant height over 2. Okay, really important that you notice the repetition going on here so you don't feel so overwhelmed memorizing. Take a note that these 2 lines, exactly the same thing, except P and circumference are replaced. These 2 lines, exactly the same thing, except perimeter and circumference are replaced. So you're only memorizing half. If you just remember perimeter of a prism is the same thing as circumference in a cylinder and a cone. The last one we have here is a sphere. The surface area, there is no lateral area, so we just write here, it's going to be 4 pi r squared. Make sure that gets in your reference booklet. You're going to be able to use that when you do your lab.